Every app, website, and AI tool you use exists thanks to different fields of computer science. From cybersecurity to game development, each area shapes technology in unique ways. But how do they connect? And which one might be right for you? Whether you're just curious or exploring a tech career, this video breaks down the major fields of computer science, what they focus on, and how they power the digital world. Without further ado, let's dive in. Computer science is the study of computation, algorithms, and information processing. It explores how computers work, how they solve problems, and how they can be programmed to perform complex tasks efficiently. At its core, computer science involves designing software, developing algorithms, managing data, and understanding the underlying hardware that powers digital systems. It spans multiple fields, including artificial intelligence, cybersecurity, computer networks, and software engineering, all of which contribute to advancements in technology. Whether it's creating smarter AI, securing sensitive data, or optimizing computer performance, computer science plays a fundamental role in shaping the modern digital world. Now, let's take a look at different fields of computer science. First, we have theoretical computer science, the field that explores the fundamental principles of computation. It focuses on algorithms, computational complexity, formal languages, and the limits of what computers can solve. Concepts like big O notation help us measure algorithm efficiency, while graph theory plays a key role in everything from social networks to mapping applications. One of its biggest unsolved questions, the P versus NP problem, challenges our understanding of what problems computers can solve efficiently. Even areas like cryptography and AI rely on these mathematical foundations. Without theoretical computer science, modern computing would lack the structure and efficiency that power today's technology. After understanding the theoretical foundations, the next step is applying them to real-world problem solving. Data structures and algorithms form the backbone of efficient computing, enabling software to process information quickly and effectively. Algorithms define step-by-step procedures for solving problems, while data structures organize and store information for optimal access and manipulation. From sorting algorithms that speed up searches to binary trees that structure databases, these concepts are used everywhere, from web search engines to AI decision-making. Mastering data structures and algorithms is crucial for optimizing performance and building scalable software. If you want to explore data structures in more detail, check out our separate video on the topic. Coming up next, let's see how computers actually execute the algorithms we just discussed. Computer architecture focuses on how CPUs, memory, input-output devices, and other components work together to process data and run programs. Despite its name, this field covers the design of all computing hardware, whether in laptops, tablets, smartphones, or embedded systems like smart appliances and self-driving cars. Key concepts like pipelining, cache memory, and instruction sets help improve performance and speed. For example, modern processors use techniques like parallel processing to handle multiple tasks at once, dramatically increasing efficiency. Understanding computer architecture is essential for designing software that fully utilizes a device's capabilities. For a general overview of hardware components, check out our separate video on the topic. Next up, let's look at the software that brings computer hardware to life: operating systems. An operating system, or OS, acts as the bridge between hardware and applications, managing resources like CPU scheduling, memory allocation, and file systems. Whether it's Windows, Linux, Mac OS, or even mobile OSs like Android and iOS, these systems ensure programs run efficiently while handling tasks like multitasking, security, and user interaction. Without an OS, using a computer would be incredibly complex, requiring users to manually control hardware operations. Understanding operating systems is essential for anyone working in software development, cybersecurity, or system administration, as it forms the backbone of modern computing. Moving on, let's talk about computer networks, the field that enables devices to communicate and share data. From local Wi-Fi connections to the vast infrastructure of the internet, networking focuses on data transmission, protocols, and security. Key concepts include IP addresses, network protocols like TCP/IP, and cybersecurity measures like firewalls. Without computer networks, there would be no web browsing, online gaming, or cloud computing. Our digital world depends on seamless connectivity. Whether you're interested in network engineering, cybersecurity, or cloud computing, understanding networks is crucial for keeping information flowing efficiently and securely. If you want to dive deeper into networking, check out our networking playlist for more in-depth explanations. Next, let's explore the field that makes software possible, software engineering. This area focuses on designing, developing, testing, and maintaining software applications, from small mobile apps to large-scale enterprise systems. Software engineers follow structured methodologies like Agile and DevOps to ensure efficiency, reliability, and scalability. Key concepts include version control, software testing, and design patterns, all of which help developers create maintainable and high-quality code. Whether you're interested in web development, mobile apps, or large-scale software systems, software engineering plays a crucial role in shaping the digital tools we use every day. Up next, we have databases and information systems, the field that focuses on storing, organizing, and managing data efficiently. It includes relational databases like MySQL and PostgreSQL, as well as newer technologies like NoSQL and cloud-based databases. Concepts like SQL queries, indexing, and normalization ensure fast and reliable data access. This field is crucial for powering everything from business applications and financial systems to social media platforms. With the increasing demand for data-driven decision-making, expertise in databases and information systems is highly valuable across many industries. Moving on, we have artificial intelligence and machine learning, a field that focuses on creating systems that can learn, adapt, and make decisions. AI spans a wide range of technologies, from machine learning algorithms that detect patterns in data to neural networks that power speech recognition and image processing. Key areas include natural language processing, computer vision, and reinforcement learning, all of which are transforming industries like healthcare, finance, and autonomous systems. Whether it's recommendation algorithms, self-driving cars, or advanced chatbots, AI and machine learning continue to push the boundaries of what computers can achieve. To learn more, feel free to check out our playlist on artificial intelligence. Now, let's talk about cybersecurity, the field dedicated to protecting systems, networks, and data from cyber threats. As cyber attacks become more sophisticated, cybersecurity experts work on areas like encryption, network security, ethical hacking, and threat detection to safeguard sensitive information. Techniques such as firewalls, intrusion detection systems, and multi-factor authentication help prevent unauthorized access. From personal data protection to securing national infrastructure, cybersecurity plays a vital role in keeping the digital world safe. For a deeper dive into cybersecurity concepts, check out our cybersecurity playlist. Next up, let's explore human-computer interaction, or HCI, the field that focuses on how people interact with computers and how to design technology that is intuitive and user-friendly. HCI combines computer science, psychology, and design to create interfaces that enhance user experience. This includes everything from website layouts and mobile apps to voice assistants and virtual reality. Researchers in this field study how users behave, aiming to improve usability, accessibility, and efficiency. Whether it's designing touchscreen gestures, adaptive interfaces for people with disabilities, or AI-driven assistants, HCI ensures that technology is both functional and easy to use. Next, let's look at computer graphics and visualization, the field that brings digital images, animations, and interactive visual representations to life. This area covers everything from 3D modeling and rendering to real-time graphics used in video games, simulations, and virtual reality. It also plays a crucial role in scientific visualization, helping researchers interpret complex data through graphical representations. Techniques like ray tracing, shading models, and GPU acceleration are essential for creating realistic and efficient visuals. Whether it's blockbuster movie effects, medical imaging, or architectural simulations, computer graphics continue to push the boundaries of what we can see and interact with digitally. Coming up next, let's explore data science and big data, a field that focuses on extracting insights from vast amounts of information. Data science combines statistics, machine learning, and programming to analyze patterns, make predictions, and drive decision-making. Meanwhile, Big data refers to handling massive datasets that are too large for traditional processing methods, requiring specialized technologies like Hadoop and Spark. These fields power everything from personalized recommendations to financial forecasting and scientific research. As data continues to grow exponentially, expertise in data science and big data is becoming more essential than ever. Next, let's take a look at robotics and embedded systems, a field that combines hardware and software to create machines capable of interacting with the physical world. Robotics involves designing, programming, and controlling autonomous or semi-autonomous machines, from industrial robots to self-driving cars. Embedded systems, on the other hand, are specialized computing devices built into everyday objects like smart appliances, medical devices, and automotive systems. These systems often require real-time performance and efficient power usage. Whether it's automating tasks in factories or enabling smart home technologies, robotics and embedded systems play a key role in merging the digital and physical worlds. Moving on, let's explore distributed and cloud computing, a field that focuses on how computers work together to process data and run applications efficiently. Distributed computing involves multiple computers collaborating to solve complex problems, often breaking tasks into smaller parts to be processed simultaneously. Cloud computing takes this concept further, providing on-demand access to computing resources over the internet, enabling services like file storage, streaming platforms, and web hosting. Technologies such as virtualization, containerization, and serverless computing make cloud platforms scalable and cost-effective. From massive data centers powering the internet to decentralized blockchain networks, distributed and cloud computing are the backbone of modern digital infrastructure. Next, let's dive into quantum computing, a revolutionary field that challenges the very foundations of classical computing. Instead of relying on bits that represent zeros and ones, quantum computers use qubits which can exist in multiple states simultaneously, thanks to quantum superposition. This, along with quantum entanglement, allows them to perform certain calculations exponentially faster than traditional computers. While still in its early stages, quantum computing has the potential to revolutionize fields like cryptography, material science, and complex simulations. Researchers are actively working on making quantum computers more stable and scalable, bringing us closer to unlocking their full potential. For a deeper dive into quantum computing, check out our separate video. Before we wrap up, let's talk about an essential aspect of computer science, its ethical and societal impact. As technology advances, it raises critical questions about privacy, security, bias, and accountability. From AI-driven decision-making to data privacy concerns, the way we develop and use technology affects individuals and society as a whole. Ethical computing focuses on responsible development, ensuring fairness, transparency, and security in digital systems. Governments, organizations, and researchers continue to explore regulations and guidelines to address these challenges. As users and developers, understanding these ethical considerations helps shape a more responsible tech future. In conclusion, computer science is a vast and ever-evolving field, shaping the technology that powers our world. From the foundations of theoretical computing to cutting-edge advancements in AI, cybersecurity, and quantum computing, each area plays a crucial role in driving innovation. Whether you're interested in building software, securing networks, or exploring the future of computing, there's a place for everyone in this field. As technology continues to evolve, staying curious and adaptable is key. Hopefully, this overview has helped you better understand the major fields of computer science and which ones might interest you the most. This marks the end of our journey through the fields of computer science. If you found it helpful, consider subscribing to our channel and liking the video. Feel free to check out our other videos on related tech topics, and follow us on Facebook and Instagram for more content. Thank you for watching.